So, yeah, it works. So, hi, you already know I'm Tim now. I want to talk about Go and the 12 years we have with it from 1.0, which is quite a long time. Let's talk a bit about me, not too much. I'm Tim. I'm doing software now for like over 12 years. Technically more, like I started in school, like probably many of you. And I saw a lot of stuff that needed to be refactored, so I thought, let's talk about it. And I do more than 5 years of Go now. I came from a PHP background and decided I want to do something new, something cooler. And that's after learning Haskell, I ended up with Go. So refactoring is a big topic, and why I want to talk about it is everywhere I went, in every company, you will never end up in this position where you join and the code is just fabulous. You never saw that, wow. And every engineer also knows we have some tech that we need to work on that. And Go is pretty new, so we're moving fast, but we're still building stuff. And the agenda is for this talk, first we're going to talk about 12 years of legacy, that's the next thing. Should we refactor is a good question. I think engineers are always eager. We should consider the risks and what we're targeting. We have a little conclusion and then tell you how much does Talon.One actually invest into refactoring and why we do that. And yeah, then I want to have a question anecdotes part. I also give you answers if you have questions, but I would really love if some of you maybe have something to say about this topic too and share some experience actually. So, 12 years to legacy. Go is now 12 years old since 1.0. If you compare to other technology we're using, even stuff like PHP and JavaScript, it's pretty fresh. If you compare it to Python and stuff, it's really looking young, but if you compare it to Goofer lifetime, it's actually like 2.5 Goofer generations that we already spent writing Go code, and it's 84 dog years out of. So it's getting old, and there's also a problem that the newer the technology is, like the faster you produce legacy because you don't know what you're doing. Like you know what you're doing, but you don't know what you're doing with the new tool. And so in the beginning you build faster legacy. And I think that's especially true for Go, because a lot of people came from other languages, maybe some from C++, some from PHP, from JavaScript. And then they came with the ideas that we needed to like make Angelo sculpting down from the stone. We had to sculpt down what Go actually is. So, start with the first question. Should we actually refactor? If you ask, if you want to sell it, this is actually what this is about. You go to your engineering manager, hey, I want to refactor something. What they gotta hear is, hey, I want to change this. It will be expensive and do the same thing afterwards. So can I do it? The best argument is we can make maintenance cheaper because you touch it, it takes you hours and hours, but you can change it. Invest 10 hours and save 1 hour a week. That's a good pitch. Maybe the structure of the code doesn't cover your needs anymore. I mean, I think a lot of people here worked in a startup where you start with like 2 features and like 2 years later you have 200. And it doesn't work, things don't fit together anymore. That is also a good reason to just say, hey, we need to invest time into improving what we have. Also, maybe you have made the experience, you hired somebody new and they looked at your code base and were like, ooh, what's going on here? This is a good red flag. Maybe you should consider that because onboarding is expensive. And if you can find a way to make that better, and also you will also improve the dev experience so you keep the people. And if you're doing the refactoring, you make your life easier. That's usually what you want in life. Also, dependencies and interfaces are outdated because Go is new, a lot of things happened, a lot of things changed. Maybe you have like a repository that's still on Go 1.0. Maybe you should consider that because dependencies run out of time. So I think these 4 things are good to pitch, hey, why we need to do a change that's expensive. One thing I would suggest you're not saying, like I was a team lead once, if you said it to me, I would say no, is the code is bad. Because code is the code you wrote 6 weeks ago is bad. What makes good code is knowing the code, being familiar with it. Then you say, oh, it's good because I understand it. But the person, like bad is not an argument. And the business, like, explain to me why it's bad. Good luck. So, also there's some risks with refactoring. You're not going to just get it and it will happen and it will be wonderful. I think everybody here in the room probably had a rewrite project that was taking way longer and never finished, and you had to answer confident questions, so let's talk about the risks. First, return on investment might be low. So return on investment means you invest, let's say, 500 hours, and for the business that means you somehow need to save 500 hours plus. So might be low. Maybe you have a service that's really crappy and you don't want to touch it, but you have to touch it once a year for an hour. Like, why would you invest hundreds of hours? You're going to get it back. So you have to just accept that. It's also really easy to build really abstract code bases, because let's say you have a code base that's 10 years old, and once a year people go, let's refactor it, you will not have a concise idea implemented in code. You will have 11 ideas mixed up with each other, spaghettifying the whole thing, because I don't understand this, so I built a module there, and that needs this, and then suddenly you cannot build anything, because everything depends on things that everything depends on. Also, keeping things simple, stupid. I don't know if it means keeping things simple and stupid, or just simple stupid, but it's also a risk, because usually the complexity of a business grows over time. And if you fight against the complexity in your code base, making things simpler at some point makes it harder. So maybe consider that refactoring to make things easier is not really a good idea. And I will have a solution for you later in the talk, what you should do instead, so stay tuned. And same is true with dry. People make fun of like distributed monoliths and microservices. This is exactly why you have that big thing, because like Uncle Bob came with a big stick and pushed it to you, don't repeat yourself, and then you have this utils package everybody shares. So you don't want that. So this can happen with refactoring over time. So just some risks. So when we do refactoring, and we do a lot of refactoring, we have some targets that we want to hit to make it worthwhile from a business standpoint, but also from enjoyment factor. First thing is, you want to use as much of the standard library if you don't have a good excuse, instead of the third-party libraries, because third parties have issues. Obviously, if you follow the news, third parties can be a security risk to you. You cannot really audit it. You get it from some person, and it gets old, and stuff like this. The standard library is updated, it's easier to update. And many problems that were solved in the standard library too, especially with the HTTP server and routing. I remember when I started, you couldn't have like variables and paths and stuff like this in Go, in the inbuilt server, and so everybody used Gorilla Mux because, well, you need that, like if you're not building something really simple. So that changed, and error handling got better. You remember when you had to like grab and unwrap errors of like some packages from GitHub? That's technically over, so you can do it now with yourself, reduce the code base. This is a big thing, like we at Talon.One, we think context is a good thing, and build our own, and then go standardize it at some point. And also when you rebuild your context, maybe you should consider that it's not a dependency injection way of doing things, because that is something that I think a lot of people saw. It's like, oh, context, so I can push everything I could ever need into the context. So this is also a good target for refactoring. We know of like concurrent maps, so if you do a lot of concurrency, you might want to use a map. That is a cool thing, and there's IO packages. We have Go embed now, so you can like, if you have templates, maybe it makes your delivery easier. And generics, and a lot of things, especially in performance improvement. So go and update your standard library and try to remove things that you already have in your old code. Next topic for me that is really important is procedure code versus object-oriented code. I don't want to argue which is better, because we don't have enough time for that. But Go, I think, is much better if you think more procedure instead of object-oriented, because I don't think it was built to be object-oriented. One thing is build strong packages, don't build classes. This is a really abstract thing to say, but I see a lot. Model view controller stuff, for example, where you have like these setups. So packages must own their own interfaces. I think that is really important, because Go does not support like circular importing. And if you use interfaces from other packages, you're automatically importing the other package, making that problem worse and worse over time. That is something we had to fight with sometimes, but we wanted to build something, and it could have been easy, but with circular dependencies, so we had to fight with that. Same true with functions. They should receive interfaces and return values, because it's the same thing. If you receive an interface, and I will double down on this, I have actually one code example for this, you add more dependencies that you don't need to add, and the same is with values. If you return an interface, whoever wants to use you has to import you, because they have to have your interface, and that is again building dependencies. And I double down on this because this is a big problem in a big Go code base, because you can't build diamonds. Also testing, we had a lot of mocks. Mocks are cool, but you can do most of the things that go with stubs really easy, and building stubs is also really fun. That goes back to the interface thing. If you have the interfaces, building stubs for it is easy. And yeah, removing anything model view controller. I once had somebody tell me, Tim, model view controller never fails. And that might be true, but it's not necessarily fun, especially again in Go, because then you have this models folder, this views folders, there's controller folders, and all your domains are smeared around that, and then you have more packages where it's more of the domain. You don't want that, you want to have strong, concise packages. And yeah, write few longer functions. Sorry for hitting on the ball again, but I think at some point, having a long function where everything is in the function, you can easily understand it, is much easier to understand. Really, really from top to bottom, you know what it does. If you have like battles, like we have a billion functions and all of them are 2 lines long, I don't think that's easy to read, easy to work with, and I don't think that is a good thing. There's always a point. Don't have like I saw things, but like 50, 60 lines are maybe okay. Accept that. And yeah. So as I said, I want to double down on that and give you a little code example because this was really something that is, I think, core to Go, and this is really different to a lot of languages. So let's go into that. So you can see here, we have like this little health check handler that just takes the PGX pool and pings it. So like, hey, are you still there? Everything is fine. Returns an error is not otherwise. So what you do is you already have the PGX pool dependencies and you inject the whole thing for testing that in the health handler. Like, how are you going to do that? Probably you download Mockery and try to run it and hope it works. But what you can just do, put your interface there. That's just a copy of the PGX pool ping. Put it as a parameter in your function. Require this, and you can put in the PGX pool. You can put everything that does the ping, and you don't have the dependency. You're not going to build circular dependencies. And it's much cooler, and it's easier to test because all you need to build is like this stub. It just has a ping value, it has a ping time duration, we call it as a timeout in the context. Really easy to do, easy to test for the function. Obviously, this is a simple example, like to-do-list way, but this really saves sort of mockery and executing the list correct and stuff like this. So yeah, focus on your interfaces. Another topic is being specific over being generic. Usually there's a test if you should build a generic solution. Go on GitHub and see if there's already a generic solution. If there's not a generic solution, there's probably a reason for it. Oh my god, like you see? Because if there would be a relatively easy, fun way to build a generic version that really covers a lot, that would already probably be on GitHub because somebody would have done that to get a better job. So, so consider that. So, generic versus specific code. Usually you try to predict the future, and that's why you want to write generic code, because you're going to say, we write it generic now, so we don't have to do it later. And 2 things happen. First of all, it won't happen, mostly. So you build a generic thing, and it doesn't really help you out. It doesn't promise. You just invest more time in the beginning to build something that you're not going to use. Or you build it, and it can do what you want, but just like 50% of it, and then you have to touch it again and change it. And then you also probably, like, it's generic, so it's everywhere on your code base, and you want to change something, so you have to change it everywhere. And then you have like this pull request with a million files, and your colleagues are like, what's going on here? So don't do that. So also, if you build a specific solution, you have less code usually, and you do not connect unrelated code because you have not the situation with this is generic, this is there. It's like it's a specific thing. I know it's not easy. It's like it's hard to do, easy to say, but focus on that, and you will build better packages, and don't burn your code base for the future. This is my favorite slide, because this is also something you like to discuss with me. It's throwawayability over maintainability. If you have a better way for throwawayability, I'm happy to get it. But the concept is really easy. If you can throw away something and rewrite it in 8 hours, it's better than reading and understanding something 20 hours to then maybe rewrite it. So this is not an invention. I don't invite you to write shitty code where you're like, hey Tim, this code is really bad, but I optimize it for throwawayability, so you don't want to keep it. So this is not an invite, I just want to make that clear. So the problem with maintainability is you cannot falsify it. Like, how would you prove that your code is maintainable? Because it will turn out in X years, X person will work on it, and then the person will decide if it's maintainable. And if you ever took over old code, your decision if it's maintainable is probably no. So it's really hard to optimize yourself. Like, how would you do that? And also code will change into unmaintainability, simply because we refactor the code, we work on the code, we change it. So making it optimized now might be true, but how will it look in 5 years? So what you really want is make it throwawayable code. So code that you can just replace with new rewrites. And that is also falsifiable, because you see how many dependencies it has. You see how big it is, and how many interfaces it has, and how the interfaces are made. If you have a piece of code that has like it's a package with 1 million lines, and it has so many dependencies and everybody's depending on it, then that is a sign that you cannot just throw it away. And the solution here is build as small as possible packages, keep the dependencies low, and you notice I hammering in the dependencies because that is usually trouble. And if you have the good interfaces, you will be able to rewrite something faster than you need to understand it. And if you rewrite it, you also don't end up with a mixed code base where like 10 people wrote this one piece of code. But after 10 years, when you rewrite it, or 5 years or 3 years, you have one idea in the code again. So, what is my conclusion for Refactoring Go is weigh the cost against the usefulness. So, is it really necessary to do it? I know as an engineer, I want to do refactoring all the time, improve it, thinking. It's really fun to think about things and make it better. But usually we have to think about business. Also avoid new levels of abstraction, keep your abstraction low. Adding more abstractions makes it easier for you to build something and easier for everybody else in the future to understand how it works and go through it and like get the pasta out of the code. Manage and own your interfaces. This is, I think 50% of the talk is what that is, but this is really the most important thing because this is when you stop being able to move and go, is when you have your circular dependencies. Focus on reducing the dependencies. Like, you don't need the dependencies, get them out there. And don't solve future problems. This is a big one. I see this everywhere, like, hey, we can build it like that, and then this will happen, and then it doesn't happen. Like, you know, these startups with like 5 customers and spend like 50,000 euros on AWS because they have like a really awesome microservice setup. It's kind of the same problem just with code. And build boring stuff that just works. Yeah, try not to do smart things. I know it's interesting, but if it's really boring and it really works, you have kind of the iPhone of code. They make billions with a boring piece of technology. And it was interesting in the beginning, but I think that is really this tactic. Don't try to outsmart yourself. So, how much do we invest into refactoring? That's a big topic. Management doesn't like it because, as I said at the beginning, we're promising them that they get the same thing, just better, without them understanding how it's better. We here at Talon.One invest 20% of our time into refactoring. We have like a tech debt Friday, so you have the whole Friday to basically refactor whatever you want. It's engineering driven. So if you, as a single contributor, think this function looks really bad, I don't like who wrote it, it's probably me, so I'm gonna improve it, you can't just do that. But it also gives us the space to just say, hey, we have a big refactoring goal, and we actually did that. As I said about the context, we can go in, invest the time, and get it done. And the best thing about it is, because you have 8 hours, or you can make it 10 hours, somebody will complain probably, you can start something and finish it on the same day. And I think, especially with this thing, refactoring, it's easy to build a lot of work in progress stuff that is never finished, that you're always restarting and never gonna do again. So this is investment. Last but not least, you're still producing 80% new stuff. So the amount of new stuff will grow faster than the amount of stuff you can refactor anyway. So I think this is a good number. And think about what you want to do, but yeah. So, thank you. That was me about refactoring. I also want to thank Vitaly and Simon. They helped me with the talk and read it like a billion times and gave me some feedback.